Hi, and welcome back to another AnyRPG Development Livestream. In these videos, I livestream the development of the AnyRPG Engine, a free and open source role-playing game engine designed in Unity and written in C#. If you still haven't grabbed a copy of AnyRPG, you can find it at anyrpg.org/downloads in both source code and Unity package format. You can also find on the same page copies of any of the games that you see me working on in these episodes. In today's episode, we'll be tackling a problem that has existed for a while, and that's the fact that we're currently getting 4.8 frames per second in the Sun Temple, and it's really impacting our ability to do anything and build anything in that level. So before we continue, I need to improve the frame rates, and in this episode we'll be going through several ways to improve frame rates. We're actually going to be going from about 4.8 frames per second currently up to about 50 frames per second, which I think will be pretty good. And I'm going to be doing that through 4 different methods. The first method is we'll be updating the mini-map that you can sort of see here and replacing the shaders on it using some great techniques like Unity replacement shaders on the camera. And these are great for making mini-maps a little more performant. The other thing that we'll be doing is we will be replacing the Luminescent model, as her geometry isn't particularly great, and it is causing actually a pretty severe frame rate drop. So I went through online and looked for basically all female 3D models that I could find that had like some sort of humanoid rig on them. And although I found some really cool ones, it took quite a while. It took me, this is like the result of about a week of searching that you're seeing right here. And none of these girls really sort of embodied the luminescence that I wanted out of this model. So what I ended up deciding is just to use this girl right here from the ON3 male and female races free asset on the Unity asset store and just make her hair blonde, and we'll just use her as a placeholder until I can find something really great. There was one that sort of embodies what I'm looking for, and 3D model here. Let's see if I can find it. There we go. This one right here. And she's on Sketchfab. However, when I downloaded her, unfortunately the dress has like its own animation, and that makes it so that I'd have to be like a Blender expert to be able to fix it, because there's a whole pile of blend shapes in the dress and I couldn't get it to conform to her body properly. But this is sort of the look that I'm going for, you know, just something like sort of glowing. I spent about a week trying to get the FBX model that I downloaded to work, but in the end her body just kept on poking through the dress and she was all nude, and I'd have to make this an NSFW video, and YouTube algorithm wouldn't be very good if I showed her. So we're just going to skip that and go with this ON3 female. So let's get started on the improvements. So first I'm going to demonstrate the baseline right here. Then I'm going to show how, or basically set a benchmark for what kind of frame rates we want to go, and then we'll go through and actually fix everything here. So you can see we got a black background here, we got 16 frames, 70 frames. Load up the game, and we'll see the frame rates just drop incredibly. If you haven't used this little tool here, all you got to do is just click on this stats button at the top, and you'll have your frame rate displayer right there. It's a pretty neat function in Unity. So as you can see, our frame rates are just like ridiculously low right here. So let's set the target frame rate, and to do that I'm just going to demonstrate what's actually possible in the Sun Temple. So if we go to the Sun Temple folder, there's a demo scene included with it, and I think we get about 70 frames per second in that demo scene. So let's just go take a look at that, because that's going to be our benchmark of basically what we're aiming for in our frame rate improvements here. So we'll open up the Sun Temple demo scene and press play. Okay, here we go. So this is the Sun Temple as it is, like out of the box when you just download it from the Unity Asset Store. It comes with like this first-person controller here, and it actually looks really, really good. This just looks amazing, and we're getting like 60 frames per second right now. So let's just go take a walk up to the top of the Sun Temple, and we'll go into that room because that room and the smoke that happens up there is part of the reason for the frame rate drops. So we'll head up the hill here, and you can see this level. It just looks completely gorgeous. You know, the reflections are amazing, and we're still getting like 60 frames per second right now. You know, there's the smoke right there, and we'll head up the stairs here. It's an absolutely gorgeous asset. It's totally one of my favorites on the whole asset store. And then we'll head in, and this is what we're looking for here, this big building right here. And we're going to head inside, and so just for reference here, alright, so here we are in the center room, and yeah, like 60 frames per second. So this is our benchmark, this is our target, what we're going to be trying to accomplish for our frame rates in here. So let's pop out, and then head back in and just see in the editor like if there's anything that we can do even without code just to demonstrate. So we'll go back to the load game manager, the Lost Soul version, and press play, and then jump in and do some quick work in the editor that'll actually get us about a 30 frames per second improvement. So I'll just demonstrate that. Okay, here we are. So like 3 frames per second, something like that. Okay, so the major reason for this actually is due to Unity and cameras, and all the levels that we've been working with so far have been pretty simple, had pretty simple geometry, not a lot of objects in them, and so performance hasn't really been an issue, but now it definitely is. So if we look in our camera manager, you can see we've got a main camera, one for our character portrait, and our focus portrait, which are our unit frames, and we've got a mini map, and then a main map, and then the character preview, which is when you open the character window, the unit preview, which is when you open the unit spawner in the Arena of Trials, and the pet preview, which is when you open your pet journal. And all of these cameras are actually turned on and actively rendering. And so basically what happens is Unity has to actually render the frame once for each camera that's active. So you get 1, 2, 3, 4, 5, 6, 7, yeah, 8 cameras constantly rendering. So that's going to basically drop your frame rates to about an eighth of what they would normally be. So let's just do an experiment here. We're just going to turn off every camera except for the main camera, and then unpause the game. And you can see we already jumped from 4 frames per second to about 14 frames per second. So that's not bad. But there's even more that we can do. So you can see this old Luminessa model and the new Luminessa model, and I've got them both in the scene. And so if we look at the old Luminessa model, I haven't been able to figure out basically what was wrong with it, but, well, I mean, I have, but here's the issue. No matter what I did for the hair, which is actually where the problem is, whether, you know, I switched like pretty much every different setting on it, I couldn't get the hair to perform properly. But if you turn off the hair and make the old Luminessa bald, you can see how we jumped up to 30 frames per second already. So this was actually really unexpected to me, because you can see now the motion's smooth, the camera movement is smooth, like everything's working okay. Unfortunately, I don't want a bald Luminessa, and this Luminessa also has like this sort of issue where her neck isn't really connected to her body, so her head just kind of floats around. So unfortunately, at this point, I pretty much have no choice but to replace her with this UMA version. So you can see, I don't know what's wrong with her, but yeah, we're just going to take her out of the scene basically, and you know, we have a nice 30 frames per second now. 30 frames per second is okay, but I really want some room. I want to get us up to about 50 frames per second. So there's a couple things extra that we can do to get us there. One of them is actually changing the rendering path on the camera. And our graphics settings, I think, have it set to forward right now, which means it has to do multiple graphics passes. If we set it to deferred, we can actually get a fairly decent performance boost. There you go, 50 frames per second. So just with a couple of tweaks in the editor, we've managed to actually take this from 5 frames per second to 50 frames per second, and this is basically what we're aiming for. Now the problem, of course, is right now if I click on her, I don't get her unit frame showing up, and if I click on sunlit over here, it's just black, it's not showing her. And if I click on the map, actually I have some code that'll actually make the map work, so we'll talk about that later. But you'll notice if I move around, let's just remove this stats window here, you can see nothing's moving on the mini map here. So sure, we disabled all the cameras, we got these great frame rate improvements, you know, we can, like, if we head over into the back here where there isn't any complex smoke, we can even get like 60 frames per second. And I mean, this is pretty good. This is comparable to what the default Sun Temple scene was doing. So I'm definitely happy with the performance here with this 66, 70 frames per second. But we've lost a bunch of capabilities in our game to do that. So the good news is we don't have to worry. We don't have to live with a black character screen or a pet journal that doesn't show any pets. We can actually have our cake and we can eat it too. So to do that, we are going to have to just make a couple of improvements to the camera system, and for that we're actually going to have to go into the code. So let's jump into the code and start making some sane defaults for our game. So first though, I'm just going to remove all these example characters here from the load game manager, because that's actually causing the load game manager to take a while. I just had them in here for testing purposes basically. So we'll get all of them out of the way here. Alright, that's better. So the load game manager just has the load game manager in it now. And now we'll go to the Sun Temple and we'll remove the offending Luminessa model. Oops. Sun Temple. So under the NPC folder, if we hit F to focus on her, you can see this is the old Luminessa model, and then there's the new Luminessa Uma model standing beside her that we're using. So we're just going to remove the old Luminessa model from the scene and save that. Perfect. And then we can go back into the load game manager and start making some changes to our cameras. So let's just revert that, because I actually have deferred as the defaults on these now, and we'll revert the rendering path for pretty much everything. Unfortunately, although you can set a deferred rendering path on most of the cameras, you can't on the mini map or main map, because those cameras are orthographic, and apparently orthographic always has to use forward rendering. So we can change it on all the other ones though, and get some good frame rates out of that. Okay, now the next change that we want to make here is actually to disable any of these cameras when they're not in use. So there's no reason for the pet preview camera to be active when the pet preview window isn't open. Just like there's no reason for the unit preview camera to be active when the window isn't open. Same for the character preview camera, don't need that active unless that window is open. And for the main map camera, we also don't need that active, because previously the main map camera was like active and recording the main map all the time, and really we only need to take a single frame of that. So we're going to go into the code and actually just use a method to make the camera render. You can actually just call a render command on a disabled camera and it'll just render a single frame, so that'll work a lot better. And the mini map camera, of course, we actually do need that on, but we're going to be using some replacement shaders to make that thing a little more performant as well. And the focus portrait camera does not need to be active when there's no focus active. And of course the character portrait camera does need to be. So let's just save that. And now we can go into the code. And basically what we want to do is look for any place where we're setting our cameras active, and we pretty much want to be setting these things to false. So what I'm going to do is I'm just going to look for that string anywhere in the code, because I've just gone and commented this stuff out for demonstration purposes, but we'll have any camera that's not active on their clear target methods or close window methods just automatically disable the camera. So we'll just click on find all, and that's going to find all the places in the code where we've got that. So when we clear our target on our unit frame, we're just going to disable the camera. When we clear target on our preview camera, we'll disable the camera. Same thing with our pet preview. When we clear our pet preview target, we'll disable the camera. And that'll cover all those instances there. And then for our main map, we can automatically disable that at the awake method, so that that's not going to be active by default. And when the window gets closed, of course, we're also going to be disabling that as well. And then you can see that when we open our window and we're initializing the map, we just use this camera.render, and it'll just render a single frame so that we don't need this camera active all the time. So same for the unit frames on awake, we're just going to disable the camera. Alright, so let's save all those. So now let's jump back into the game and just see how this thing is performing out of the box now. And of course we'll just confirm that all the changes that we just made worked, and that we're actually having disabled cameras for everything that's not needed right away. Okay, so we're sitting here at 17 frames per second right now, which is definitely not quite as good as we'd like it to be. So let's just pause this for a second and go take a look at our cameras. So you can see the main camera is active, and our character portrait camera is also active. Our focus portrait camera is not active. Our mini-map camera is active. Our main map camera is not active, so that's good. And the character preview, unit preview, and pet preview cameras are all not active. So this is pretty good. We've basically only got like 2 cameras rendering right now. One of the things that we can do, let's just take a look here for a second. So if we hit M to open up the main map, you can see our frame rates drop to 6 for a second and then jump back up, and that's just because we were rendering. And if we press pause and take a look at this main map camera, you can see it's still disabled here. So basically the code change that we made in order to just have the thing render a single frame is working, and that's great because there's no reason that a map this big needs to be updated in real time. So we're still getting like 15 frames per second. So if we were to, for example, look at the character portrait camera here and just go ahead and disable it, actually surprisingly that didn't really help a whole lot. But for performance reasons, I actually do sort of want that option. I'd like the option to just have a portrait camera that doesn't necessarily need to update in real time. So we can do the same thing with the portrait camera. We can set it to basically just render a single frame whenever we take a snapshot of someone. So let's go ahead and do that. So the portrait cameras are controlled by the unit frame controller. So somewhere in here we're going to have a set target method right here, which enables the camera. So what we're going to do is we're just going to add an option to not need real time on the camera. So let's add a new serialized field here, and this is going to be a private bool, and we'll call it real time camera. And it's going to be actually false by default. I think I want the default for this game to be like as high performance as possible. So we'll just have that set to false. And when we set our target right here, if real-time camera is true, then we're going to enable the camera. Else, we're just going to take our preview camera dot render, exactly like we do in our main map. So let's save that. Jump back into the game. Okay, so we actually don't have a preview of that guy. Looks like we don't have a preview of Sunlit either. So I'll have to make some changes to that. Interesting, so now we have a little bit of a lag in that thing. I think what I'm going to do, I think I actually just need to set a coroutine to give it like a single frame or something like that. Because what we actually have to do is somewhere in here actually we're getting a follow target. And then our camera actually has to move to the follow target. On its update method. So we actually just need to wait a single frame. So to do that, what we can do is we can actually just set a coroutine that just runs for a single frame. So we can just make a private IEnumerator, and we'll just call it wait for camera. Actually, yeah, that's fine. So yeah, private IEnumerator, wait for camera, and we can just do a yield return null, which basically just makes it wait a frame. And then we can put our preview camera.render in there, and then we can pull that out and just do start coroutine, wait for camera, and let's try that. Okay, so it took a snapshot of our UMA guy when he was still in his T-pose and before he actually had his equipment on. However, the snapshot of Sunlit is working okay, and the snapshot of Fission is also working okay. So I think I'm gonna have to make some modifications to detect if it's an UMA unit, and then perhaps just have the thing render the frame when the UMA units close or on after an update method. I'll be doing that at a different time though. For now, I'm pretty happy with the fact that that is at least working. Let's just go into our unit frame controllers and just check the box for real time and just confirm that the real time actually works as well. So to do that, we have our focus unit frame right here. And let's just check real-time camera, and then we also have our player unit frame, and we'll just check real-time camera on that and just confirm that these things are updating in real time now. Okay, so that looks like our guy. He's lifting up his hand, and our camera's following Sunlit around. Perfect. So our new focus and target or player unit frames are working good. So we're just going to revert that setting, and on our focus unit frame we'll just revert that setting as well. Whoops, right click, revert. There we go. Okay, good. So save that, and the next thing that we have to do is in our project settings under quality, we have our shadow mask mode as distance shadow mask. If we change this to shadow mask, we actually get a pretty big boost in performance. So let's just press play and see what the difference there is. Basically, I believe I think you can like read about it, the specific distance, or difference. But distance shadow mask renders real-time shadows within the shadow distance on the camera, whereas regular shadow mask does not. It's using pretty much entirely baked. So there actually isn't really much of a difference on that right now. Yeah, about 18 frames frames per second, maybe a few. So let's jump out and do something about this mini-map here, because this mini-map here is like by far our biggest offender. So if we go in, you can see all these other cameras are disabled right now, except for the mini-map camera. And if we disable that mini-map camera, we just automatically jump to 50 frames per second. So we need to definitely do something about the minimap camera. So the replacement shaders is the way to go. So what we need to do is make a new script for that. So let's go make a replacement shader script. So this is going to be in our engine, under scripts, under camera, and create a new C# script and call it camera shader. We'll open that up. We'll put it in the namespace AnyRPG. So using AnyRPG namespace AnyRPG. Pop that in there. And then we're basically going to do what they're doing right here. So we need to make some shaders. Now what we'll be doing is we'll be using an unlit shader on this, and we'll be using a culling mask to reduce the number of things that we're actually drawing as well. So we'll make a new serialized field, and this is going to be our private shader, minimap shader. We'll have another serialized field, and this is going to be our private shader over, we'll just call it our overlay shader. So the reason I'm actually using two shaders right here is because if I set the minimap shader to unlit, then I'll actually demonstrate that first before I activate the overlay shader, and you can see the problem with it. But essentially we can't get the text on the minimap as well as the image on the minimap with a single shader and get good performance. So I'm actually going to take two snapshots pretty much. So on our update method, what we can do is basically just use a render with replacement shader, which is this one right here. And when we set this this tag to empty, it will basically render everything. You can read all about it on the page. It's a bit of an explanation into how exactly this thing works. But for now, we also need to get a copy of our camera. So we need a private camera, and then in the start method, what we'll do is camera equals get component camera. And we can just set this to empty. Oh, okay. Private camera, minimap camera. Okay. So let's go put that on the minimap, and I'll demonstrate why we need two shaders. Also, we'll want to disable this thing as well. So what we've done is we've disabled the camera, and then every frame we're just going to be rendering with a replacement shader. So basically, instead of letting Unity render for us every frame, we'll just be rendering manually. So let's open up this camera prefab here and add a camera shader script. And for the minimap shader, we'll be using unlit/texture. Now let's just load the game and I'll show you what that looks like. Wow, that's a really neat bug. Oh, whoops. Of course, I put it on the wrong camera. That would totally do it. Yeah, okay. So, my bad. We're going to remove that component, apply that to the main camera, and then we'll actually go in and add that to the right camera. Okay, over to the minimap camera. I actually had created this script before, but forgot and accidentally deleted it before I committed it to GitHub, so it's actually even already on there. Unlit/texture. Okay, that's better. We've got it on the right camera now. Okay, good. So you can see right now we're actually getting like 35 frames per second. So that's definitely a nice bit of a jump there. But you can see an issue right here. Basically, anywhere where we've got like those green circles that represent our character overlaid on here, they're just rendering as black squares, and that's because the unlit shader doesn't handle text elements. And I tried to combine the source code for the unlit shader with the other text shader, and I totally just couldn't get it to work because I am not fantastic at Unity shaders and have no experience with it. So for now, we're just going to do this sort of quick hack here. And basically, if I'm just going to make sure that minimap shader does not equal null. And same thing for the text shader. So if the overlay shader does not equal null, then render with the overlay shader as well. However, what you'll notice is that if we do this, we're actually just going to replace the frame. So we do have to make an update to the setting, and you can see that right here we've got clear flags on the camera. And what this means is that whenever we render a frame on this mini-map, there, we can either clear everything that's on it and set it to a skybox, solid color, depth only, or don't clear. So what we want to do is make sure that when we render the text stuff, we've actually got this set to don't clear. So what we will do is set the clear flags. So we can go minimap camera dot clear flags equals camera clear flags dot nothing. And then before we render the picture of the map, we'll be setting the clear flags to skybox. So what'll happen here is it'll clear the entire frame, render the map on top of it, and then don't clear, and then render the text on top of it. So let's just save that, and we'll jump back in, and we should see that working. Okay, and of course it's not working because I didn't actually go in and set the second shader on the minimap. So let's do that. So this is UI slash, I think it's default. I think I tried out pretty much all the UI shaders, because you need a UI shader that's actually going to render text. Actually, you know what I wonder? Can we do UI slash, I'm going to try unlit text and just see if that works. Let's actually just press play. Yeah, that doesn't really work because you can see little black squares around there. So I think actually we do need to just use UI default. Let's try that. Interesting that it's still not, it's still actually showing black stuff around there. I think I might have still got the wrong shader there. Might be UI lit transparent. This crash right here is, I looked online and it's apparently a Unity bug where swapping shaders out can occasionally result in that, like the first time that you load. Let's just try loading again. Okay, so that was definitely not the right shader. Actually, I think what's actually happening here is the culling mask is wrong. I think I need the culling mask set to basically just minimap on the second run. So to do that, we can actually set culling masks. So on the first run, actually, I think I had the shader right, but I just needed to set the culling mask properly. So minimap camera dot culling mask equals, and we actually need to create a mask right here. So to do that, we need to get a bunch of layers, basically, and we can do that in the start method. So the layers that we need specifically for this are default, water, and walkable on the first run. So default layer equals layer mask dot name to layer. And that's default. Right, and of course we need to make some ints, so private int default layer, private int walkable layer, private int water layer, and private int minimap layer. Okay, so now we have some layers, and now we need to actually set the culling mask. So to do this, we need to basically combine the layers using bit shifting. So what that means is we take the default layer and combine it with the walkable layer and the water layer. And before we render the text, we don't need to combine it with anything. We just set our culling mask to the minimap layer. Alright, let's save that and test that out and see if that's working. And I'll also actually need to change the shader here. So the overlay shader, I think I actually had it right the first time. It was actually doing what it was supposed to properly, but it's just the unlit texture shader was rendering those black boxes underneath because we hadn't removed the minimap from it. So I think I can actually go UI unlit text, possibly. Well, actually no, that's right. I think what was it again, the first one that I used? It was just UI/default. Let's test that. Okay, that's a lot better. Yeah, perfect. It's working. So good. We're getting 30 30, 33, 34 frames per second. And the text is actually rendering properly. So that was what was the matter basically, was the culling masks just needed to be set so that this first render here, where it actually renders the actual map, isn't picking up the mini map and renders a black square pretty much. So this is all pretty good, except for we can even make some more improvements to this. So one thing about this mini-map is that it doesn't necessarily need to be updated in real time. It's a mini-map, so we could basically reduce the frame rate on it, which would actually improve our overall frame rates. So let's go ahead and do that. We've got to do that, we'll actually need, let's see, a target frame rate and a bool called limit frame rates. And by default, we'll make that false. And if it's true, we'll need a private int target frame rate. And let's just set that to 10 by default. And then we'll need a private float accumulated time to keep track of the amount of time passed so that we can work with our frames. And then we'll need a private float frame length equals 0f to manage our frame calculations. So let's set that up in our start method. So basically our target frame rate is 1 over, or like our actual frame rate or frame length is 1 over our target frame rate. So if limit frame rates then what we want to do is actually set our frame length. So frame length equals 1 over the target frame rate. So what this will result in is if we set our target frame rate to like 30 frames per second, then our frame length will be 1/30th of a second. If we set it to 10 frames per second, it'll be 1/10th of a second. So then we'll actually want to take this method and put it inside of its own method here. So we'll just make that a public, just call it void capture frame. Frame rates is false, then go ahead and just capture a frame. Otherwise, we won't even worry about that. And in the start method, if limit frame rates is false, we only want to do this if limit frame rates is true. Actually, no. Never mind. We don't even need that here. Okay, so what we do want to do is else here we need to perform some calculations. So what we need to do is add to the accumulated time, time.delta time on every frame. And if the accumulated time is greater than or equal to the target frame length, then we are gonna capture a frame. And what we will do is is go accumulated time minus equals frame length. So the reason for this right here is basically if we, let's say we go over our target frame length, we don't just want to reset accumulated time to 0 because we won't actually hit our target frame rate. We have to basically add the remainder back onto accumulated time to make sure it's accurate. Otherwise, we'll always end up, if the frame length isn't exactly the same amount as like the time.delta time, then basically we'd actually lose frames if we don't do this here. So this, I believe, should work. Let's try that out. By default, limit frame rates is false, so we'll have to turn that on. So I'm just going to apply that texture because we know that works. And actually, you know what? Let's just test this out without the frame rate limiter active. So we'll press play and just confirm that we're still getting whatever we were before, which was like 35 frames a second or whatever. So if we look at our stats, yeah, there we are. We're getting about what we expect out of our frame rates. So then let's go turn our frame rate limiter on and limit ourselves to 10 frames per second. Okay, there we go. So you can see now we're getting like 45, 46 frames per second. So that's really good. So one thing that you notice though is like if you look at the mini map, it's a little bit choppy. It's not necessarily like real time. There's a slight bit of jump on your character. Honestly, for now, I think I'm okay with that. It's not like super great. I actually like the mini map when it doesn't really jump around too much like that. But the frame rate improvements that we are getting out of this are pretty awesome. Let's actually even just go make this more apparent. So let's lower our target frame rate to 4 frames per second on the mini map, and we'll actually see it jump around considerably more. Yeah, there you go. Now you can see like it totally jumps around. I think we'll just keep this like as an adjustable thing, basically. Let's even set it down to like 1 frame per second just to see what that does for our overall frame rates. So there are other ways that we can improve the performance of the mini-map. I'll actually want to dedicate probably an entire episode to that in the future. But one way we can additionally improve the performance of the mini-map, because the thing is, if you have a mini-map and you want it, you have to deal with the fact that your main camera's frame rates are going to drop because the entire scene has to be rendered again for the minimap camera. There you go. You can see up 1 frame per second, and now we're just like jumping all over the map. So one of the ways that we can actually fix this is, since we know basically like what the level size is, we can, we could actually go ahead and we could take a bunch of screenshots like of all of the areas of the main map at a really high resolution and save them as an array of images, and then basically, rather than actually showing the mini map or rendering these frames in real time, we could pretty much just figure out where our character is in relation to like the XY coordinates of the images in that array, and then just render the correct image. So what we'd be doing is, like, as we moved up here, we'd be rendering this image that was like a pre-taken screenshot, and as we went farther, we would sort of paste like another image over here and render it. So we'd have like basically like a cross of like 8 images loaded here at any given time. But that's something that is definitely worth spending an entire episode doing. For now, I think the frame rate limiter is pretty good. You know, I can sit here and get pretty much 50 frames per second, and the movement is nice and smooth again. And this is great because what it means is that we can actually enjoy playing around in this level. And before, like, I couldn't even mount in this level. Whoops, let's actually let that mount finish here. Before, yeah, I couldn't even mount in the level basically because the character would keep on just getting like stuck on everything. And you know, you can see the level, the frame rates are pretty good. When we're outside of the temple, it's actually pretty amazing. There are some additional things that we can do here. So in the Sun Temple level, there are more settings that we can set to even tweak our frame rates even further. So medium shadow resolution is good. Hard and soft shadows is fine. Shadow mask mode. Shadow mask is what we want. And looking at our main camera here, we are definitely using deferred. I think if we turn off HDR and MSAA, we can actually drive our frame rates even lower. And then if we go, oh right, culling distances, forgot about that. So one of the things that I noticed about the Sun Temple is that it actually has a culling distances script that you can use to basically not render anything beyond this max distance, and that's one of the ways that the default Sun Temple level actually achieves its performance. And so this is a neat thing. I don't think you can do this regularly, but you can do it through scripting basically. And what it does is it pretty much goes through like every layer in the game and basically just sets a culling distance per layer. And this isn't something that's available on the camera. If you go and you look at the clipping plane right here, you can only set a single clipping plane, which is basically like right now the main camera is set to not render anything more than 1,000 feet away, but you can't set it on a per layer basis. But this culling distances script can actually do that by setting the layer culling distances equal to this array right here. So that's an additional way that you can get performance. There are some trade-offs with this though, and let's actually load the game because I think I can demonstrate one of the trade-offs here. Here's the problem. Okay, so basically, when you look out at the map here, you'll notice how these buildings are sort of floating out there in midair. We've got really great frame rates, 60, 70 frames per second, but the buildings are totally floating in midair, and we can't see any of the mountains in the background. And those mountains were actually one of the things that really made the Sun Temple level beautiful, was like, you could stare out at the scenery. So let's just use a little wall jumping trick here. We can actually, like, it's almost like World of Warcraft, I found. We can actually use wall jumping to get over the invisible walls right here. There we go. And fall off the edge of the level and go for a walk. Now, here's a really, really interesting artifact of the culling distances, basically. So you see how these buildings are all floating in midair, even though we're close to them? I think what happens with the culling distances script is it doesn't cull if any part of the layer is inside. It's actually like has to be like the 0 point of whatever layer, the 0, 0 coordinate, or the origin of it has to be inside of this culling distance. So what that means is that even though this ground right here should be visible to us, because we're right on top of it, it's actually not, because its origin point is like way off somewhere, like more than 200 meters away from the camera. So I don't actually really like using that culling distances script unless it's absolutely necessary, because it just destroys the scenery. So let's go back and actually just disable that script, and then we can press play and head back in and demonstrate how much more beautiful things look when you don't call that stuff out weirdly like that. There. So massive distance, right? Like off in the distance. You can still see these mountains sort of disappear right here as we spin our camera around, but those things are part of the camera's regular culling, because they're like more than 1,000 meters away. Also, if you're not using the culling distances script, let's just run over the invisible wall here, and we can head down. And you can see that these houses are no longer floating in midair. Now, the funny thing about this is that this actually doesn't have a mesh collider on it, so you can actually run right through it and you can see them sort of floating from the bottom, but the culling problems basically are gone. Now, one thing that you could do is you could set this to like the layer 31, which is the always visible layer. So if you look at this script, it says always visible layers, and we have layer 31. And then if you look at the layers in the project, you can see we have a 31 always visible layer. So there actually is a bunch of scripts in the Sun Temple level that are setting certain things to that level so that you can always see them, basically. Let's go into the Sun Temple level, because I think there's actually one more thing that we can do to get a little bit of extra performance and a few extra frame rates. Actually, I think this is fine right here. Anyway, for the light, what you can do is you could set the mode to baked, where basically it's only ever going to show baked light. Whoops, I can't actually play in this level. It's going to throw a bunch of errors right here. We're going to go back into the load game manager. So I've already pre-baked the lighting in this level, so we don't have to go through that. But you can see, now we've got nice smooth frame rates. Interestingly enough, when the mouse is out of the editor here, you can see it showing like 50 frames per second, but as soon as we move the mouse into the window, it's like we drop and go down to like 40 something frames per second. It's a pretty crazy frame rate increase just for moving the mouse out. Nicely enough, you can still actually, if you just move with the keyboard there, you don't actually have to suffer the most frame drops. Although I don't know if that's, apparently this thing isn't like entirely accurate, but yeah, there we go. I hope you enjoyed that. That's just a whole pile of ways that you can tweak your performance so that you can not have to deal with all the performance issues that come with having multiple cameras in your game just by using some common sense and a few neat coding tricks to definitely squeeze some extra performance out of your game. So if you enjoyed that, don't forget to thumbs up the video or subscribe to the Cohesion YouTube channel, or just leave a note in the comments. Thank you so much for tuning in, and I will see you next time.